Alright, practice problem 8.6 says draw the Lewis structure for hydrogen cyanide, and it actually gives you the structure. Okay, so the first thing we want to do is find out how many valence electrons we have. Okay, we have a hydrogen, we have a carbon, and we have a nitrogen. Hydrogen has 1 valence electron, carbon is going to have 4, and nitrogen is going to have 5, and so we have a total of 10 electrons we need to place. The least electronegative atom is going to be carbon. Okay, so we can put that in the center. And then we can say, okay, well, we know that's bound to a nitrogen using 2 electrons. We know hydrogen is bound to the carbon using 2 electrons. So we have 10 electrons total. We just used 4 to make the bond, so we have 6 electrons left. Okay. Well, we know that we need to go ahead and put some electrons around nitrogen to make sure it has an octet. So if we put 1, 2, 3, 4, 5, 6, that gives nitrogen a total of 8, and we have 0 electrons left. However, what you'll notice is that carbon only has 4 electrons, so it's not very happy. Okay, so we actually have to say, wait a minute, why don't we take another set of electrons? Okay, so if we take these 2 electrons and we place those to make a new bond, so a double bond here between the carbon and nitrogen, will that satisfy our rules? Okay. Well, what you'll notice is that nitrogen now has 1, 2, 3, 4, 5, 6, 7, 8 around it. Carbon has 1, 2, 3, 4, 5, 6. So it's still not there. So what we need to do is take another group of electrons. So we'll take these 2. So we can take these 2 and we'll put those in. And so then we get hydrogen bound to the carbon, which then is going to have 3 sets of electrons between the nitrogen. Nitrogen still has 2 left over. Okay, so we're just moving these electrons around, and so now we'll notice that carbon has 2, 4, 6, 8 electrons around it. Nitrogen has 2, 4, 6, 8 around it, and hydrogen's happy as well. And so we can just redraw this as hydrogen bound to carbon with a triple bond between nitrogen.